Good morning, everybody, and welcome to my presentation of the article titled Effects of Treadmill Exercise on Dopaminergic Transmission in the MPTP Lesioned Mouse Model of Basal Ganglia Injury, written by Petzinger et al. In 2007. So, like we've been learning about these past few weeks, the basal ganglia is very important in movement control, and inside of the basal ganglia, we have the substantia nigra, which is important in dopamine production. So, with Parkinson's disease, what happens is the cells inside of the substantia nigra begin to die, which leads to a significant decrease in our dopamine levels. The symptoms for this disease are unintended movements, difficulty with balance, coordination, slowed movements, and tremors. This study utilized the neurotoxin MPTP, which destroys the dopamine neurons in the substantia nigra, and it creates a model of Parkinson's disease. The researchers here were asking the question, how does treadmill exercise affect a mouse model of Parkinson's disease, especially with dopaminergic transmission? Now looking at the research methods, there were four groups of mice. Saline mice injected with saline and not put to exercise. Saline mice plus exercise, so they were given the saline and were put on the treadmill. We have the MPTP lesioned mice with no exercise, and the MPTP lesioned mice that were given exercise. The lesioning led to a 60% loss of nigrostriatal neurons and 80 to 90% depletion of striatal dopamine levels. And the exercise began 5 days after lesioning. Mice ran twice a day for 30 minutes. And to control for any effects that the treadmill environment had on the mice, even the mice in the no exercise group were placed near the treadmill for the same amount of time. The researchers used a rotarod to do a behavioral analysis on the mice's balance, and they also used various methods to measure dopamine levels in the mice's brain tissue. There were several research findings, but just for time's sake, I will be giving you the most important part of each finding. The first results showed that during the first few weeks of exercise, there was a significant difference in running velocity between the lesioned group and the control group, but by the end of the experiment, there was no difference in running velocity. So the MPTP mice caught up to the running velocity of the saline mice. Secondly, they analyzed behavior on the rotarod. So the mice in the exercise group performed much better than the mice in the no exercise group. They had much better balance. And so the solid black and solid gray line are the mice that were put to exercise, and the dotted lines below are the mice that were not given exercise. Here they measured dopamine levels in the different groups, and they found that there was no difference in striatal dopamine tissue levels between the exercised lesioned mice and the non exercised lesioned mice. There was, however, a significant increase in the saline exercise mice. Here, electrodes were placed at 5 different areas on the striatum. These areas were then stimulated and the dopamine release was measured. So there was a significant decrease in release with the lesioned mice in comparison to the saline mice, obviously. And in the lesioned mice, those that were given exercise showed a significant increase in dopamine release at site 3 and 4 in the striatum. So this little circle at the top has the different sites labeled, so they showed increase at site 3 and 4. Lastly, the lesioned exercise mice showed a lower decay constant compared to the lesioned no exercise mice. Next, researchers measured the expression of striatal dopamine transporter protein and tyrosine hydroxylase, both important in dopamine production, and they found that lesioned mice, exercise or not, showed a decreased expression. Lastly, they analyzed the amount of TH and DAT mRNA in the nigrostriatal neurons. So the left of this graph is the TH, the tyrosine hydroxylase, and the right is the dopamine transporter protein mRNA. And they found that both lesion groups showed a significant decrease in TH and DAT transcription. So, in conclusion, the researchers found that exercise affected motor performance and dopaminergic transmission differently between the injured and non injured nigrostriatal systems. Both mice groups received their own set of benefits from the exercise mice. In the lesion mice, exercise led to increased release, reduced uptake, and a decrease in decay. So, for future research, they could take these findings and continue to elaborate on the role exercise plays in the enhancement of neuroplasticity. It could also be used in the treatment of neurodegenerative disorders such as Parkinson's disease, obviously, with more focus on synaptic connection maintenance rather than restoring dopamine levels. And thank you all for listening. I hope it was informative.